Well, I guess it's about time, so let's go ahead and get started. Hello, I'm T.R. Bosworth. I'm the product manager for SUSE OpenStack Cloud, and this is Rick Salveski. He's our program manager for SUSE OpenStack Cloud as well. So we're going to share the presentation. I'll start off introducing what's going on with our roadmap, and he can finish up with some of the details because he has all the technical details, and then I'll finish up with a follow-up on what's going on with Cloud 10. So this is our agenda. I want to talk about the life cycle of SUSE OpenStack Cloud, what we've done historically, what we plan for the future. I also want to talk about our major focus areas of improvement. Then I want to talk a bit about Cloud 9, what we're actually announced today that will be released at the end of this month. Then Rick is going to talk about the Cloud 9 updates. We have quite a bit fit into our Cloud 9 update, so we have an approach of delivering an initial release and then providing updates in an agile fashion. So he'll describe some of the things we're doing in our Cloud 9 updates. And then I'll talk a bit about Cloud 10, and then I'll take any questions. So that was awesome. Anyway, this is our stack, our SUSE stack. So I'm talking about SUSE OpenStack Cloud, which is our infrastructure as a service layer. We integrate and test our different layers together. The SUSE OpenStack Cloud layer allows you to use software-defined infrastructure. So you can provision your compute, network, and storage using SUSE OpenStack Cloud. So this is a view of our life cycle. We have a 3-year life cycle per release. As you can see, we've had releases before Cloud 7, but this is what's still in market. So the end of, for Cloud 7, the end of support date is December of 2019. Originally, that was May of 2019, and we extended that by 6 months to give our customers the ability to migrate off of Cloud 7 to Cloud 8. That's great music. The other thing that we're doing, you can see that with Cloud 8, we have Helion OpenStack 8 and also SUSE OpenStack Cloud 8. The Helion code base with Cloud 8 was very similar to SUSE Cloud 8. The difference with HPE code is really some light branding. With Cloud 9, that release, there will be no HPE release. So we're going to actually provide an upgrade path for HPE Helion customers from 8 to Cloud 9. So that's a big change. The underlying Lifecycle Manager that is used in Cloud 9 is exactly the same as what was used in Helion 8. So from a customer's perspective, the people that are using HPE Helion 8 will have a nice, easy transition to SUSE products. It will be fully SUSE branded, the documentation will be fully SUSE, and we'll provide that migration path from the HPE Helion over to SUSE Cloud 9.
So essentially, HPE Helion will no longer exist after Cloud 8?
That's correct. From a brand, exactly. So, we're already working, actually, that was an HPE decision, but we're providing a way forward for the HPE customers.
So does that mean so you mentioned that the mechanism that's part of Helion would be part of Cloud 9. So does that mean that for the SUSE side of people, going from Cloud 8 to Cloud 9, there'd be a more disruptive change than for the HPE people? Or are you managing two parallel sets of toolings for Cloud 9?
So basically, the underlying Cloud Lifecycle Manager that's in Helion 8 is also in SUSE Cloud 8, and it will be the same migration path. So it's really the same tooling for the upgrade from 8 to 9. It's just that there's no HPE branding in Cloud 9, and so there's no HPE documentation with the HPE brand in it, and there's no Horizon front end that has HPE colors and all that kind of stuff. But the user perspective is the same.
Okay.
So will SUSE Manager be available in Cloud 9? I don't think it's available in Helion Cloud 8 Helion right now.
SUSE Manager can be used with Helion 8 now. It's because all the underlying infrastructure is SLES. So you can use that to manage the SLES part of the deployment. Was there another question? So another thing that I wanted to show is it's quite common to have our SUSE enterprise storage plugged into a SUSE cloud. And this is kind of a picture of how they're qualified. We connect to an external SES cluster. So it kind of gives you a picture of where we are in the various life cycles. So typically, we're supporting a couple different storage releases in a cloud release. And as the new storage releases come out, we're qualifying those new storage releases with the existing cloud software. So this is just an overall picture of which Linux releases supported or used in various cloud releases and which cloud releases work with the storage releases. But in general, as soon as the SUSE Enterprise Storage comes out, we're qualifying it with the current cloud releases. And then when we start a new release of cloud, then we're picking the SUSE Enterprise Storage release that's available then and qualifying that forward. So as far as futures go, we want to make the operator experience exceptional. So we're always working on our simplifying our day 2 operations. We're also adding more network capability, new SDNs that we're supporting, new network functions that are predominant in the industry. Another thing that we're looking at is containerizing our components. I'll talk about that more in just a minute, but that's one of the major themes that we're working on in the future. The other thing that we're doing is we're standardizing our monitoring components. So SUSE has some standard componentry that we're using, like Prometheus and Grafana, in some of our various offerings. And so we're doing some standardization of that monitoring components. And then the last thing there is support for emerging technologies. We're continuing to add support for GPUs and different accelerators that are coming to be more common in the marketplace. So we have a lot of requests from people that are doing AI and VDI type applications to be able to use these accelerator technologies.
So on the standardizing monitoring capabilities, so you have Manaska?
Yes.
But the comment you did mention Manaska and the monitoring capabilities?
Right. We're still going to keep Manaska. We're making net additions into our offerings. And we'll have some slides that show kind of how that plays together. But we're going to keep Manaska for monitoring, metering metrics, and for billing purposes. And then we're going to add the Prometheus on top of that as well, so that if you want a very lightweight solution, you can use actually Prometheus and Grafana. So our new release is Cloud 9. That's going to be announced, well, it's announced today, pre-announced today, and it's going to be available at the end of this month. It's based on OpenStack Rocky. So we actually skipped over a release, and we're going to provide an upgrade path from our Pike release, which is 8, to Rocky. Some of the key things that are in there are the ability to do multi-attached storage so that you can have a shared set of storage that's shared between VMs. We do have some improvements upstream in the Ironic project to bare metal as a service. And of course, since we jumped over Queens, everything that was in Queens is going to be in the Cloud 9 release. It's based on SLES 12 SP4. We have a new UI for the day 2 operations in the CLM component. So in Cloud 8, we added a graphical day 0 installer. In Cloud 9, we're actually extending that so that you can use a graphical interface to make changes in your cloud as you operate it. Another thing that we're doing is we're adding in IP version 6 support. That's actually going to be delivered in an update. We currently support tenants with IP version 6, but we're actually going to extend that so that you can have a single stack deployment where the control plane is actually using IP version 6 as well. We're adding in Watcher support, which if you're not familiar with Watcher, it's a way to do dynamic optimization of your infrastructure. So as where you place different workloads in your infrastructure, you have the ability with a policy to make changes or balance out your workloads depending on what policy you set. With Cloud9, we are doing still, we're giving you two choices for lifecycle management. We're giving you Crowbar, and we're also giving you Cloud Lifecycle Manager. So I'll talk about that in a minute, that we're going to actually merge that with Cloud 10 to a single lifecycle manager.
So I'm a little new to this SUSE OS, so you're still going to be at SLES 12.4?
Yes.
So what's the EOS on that? So you should put in there, that's going to be the underlying for Cloud9.
Right, so it's a 3-year life cycle, and we interlock our life cycle with the SUSE Linux team. So we're going to support that through the life cycle of Cloud9, SLES 12 SP4. So that's actually just been released recently in the last 6 months or so. So there's quite a life cycle on SLES 12 SP4. And whenever we bring out a new release, we're always working with our teams inside of SUSE to, if we have a 3-year life cycle for cloud, then it automatically will filter down to the underlying technology of the Linux operating system as well. So some of the things I want to show is, or call out here, is some of the changes. If you see some of the things that are actually in bold on this, this is kind of a picture of which OpenStack projects we support. So we've added, we're going to be adding support for Designate to Crowbar. We didn't have it previously, so CLM had Designate support. That's DNS as a service. One of the things that we're actually deprecating is Freezer. Freezer was deprecated in the community. They didn't even make the Rocky release. So since it's not being supported by the community, we're adding in documentation to show how to back up the control plane, because that was one of the major use cases for Freezer in the Cloud Lifecycle Manager. The other thing that we've done is we've added support for Manila in the Cloud Lifecycle Manager. We actually did that in the Cloud 8 release in the updates, but I wanted to call it out because sometimes people don't always see what happens in the update cycle. And in Cloud 9, we'll be supporting Manila, which is file as a service for both Crowbar and CLM. Let's see, the other major change is Octavia. Load balancing as a service is really the default now in Rocky. And so we've added Octavia support for both Cloud Lifecycle Manager and for Crowbar. This is a view of the new Day 2 UI. You can see that you get a picture of what's running, and you can actually go in and drill in and make changes to various services that you have running. So it started out as an installer, and we've grown this into something that's a little bit more easy to operate and make changes in your cloud.
So is this sort of tied to the SMT server? So if you're going to be patching a control plane, you use the Day 2 to do patching, or that's sort of still going through SMT, put it on, deploy it, propagate it out?
This still interacts with the deployer. So the way CLM is set up is the deployer is actually pushing all the updates. So when you're dealing with this, you're actually talking to the deployer to make changes in parameter files, and then you're actually pushing the button and it's redeploying those changes out into your cloud.
But it's not going to be patching, so CLI is still a patching mechanism when you're pushing things out. This is just a configuration change?
This is configuration changes in OpenStack services predominantly. So if you wanted to change a Cinder backend or a parameter in Nova or something like that, then you go in and change the parameter, and then you'd save it, and then you would hit a deploy, and then it would redeploy those changes out into your cloud. So it's really talking from the UI to the deployer, and the deployer makes the changes and pushes them out into the cloud. So the next thing I want to talk about, we're very excited, we're containerizing the OpenStack deployment. And so what that means is we're using the upstream content that's in the Helm project, and we're actually cooperating with the Airship project to containerize OpenStack services and then push those containers into a Kubernetes infrastructure so that we're actually pushing out OpenStack as an application on top of Kubernetes. And so what that really allows us to do is to, this capability gives us the ability to upgrade things simpler. It also gives us the ability to scale up and scale down our cloud since it's all containerized. And we're also going to be leveraging some of the built-in HA capability of Kubernetes. So now we ship Pacemaker and we set up availability clusters, and we're going to be depending on Kubernetes instead to do this. So we're going to set this tech preview up in the Cloud 9 timeframe, and we want to get active participation by our customers to look at this and give us really quality feedback. So this is why we're doing it. Actually, this is kind of a picture or where you can actually participate. So this is the link to the beta program. And like I said, we're leveraging the upstream airship project. And so you can pick this up. This will be available in May. I want everyone to pick it up and give it a try and give us feedback. We're very excited. It's a major milestone in us progressing to Cloud 10.
Well, this containerization enhance the patching process in terms of the amount of time it takes to patch?
Yes. Yeah, the idea is that you'll be able to put a new container in of a new level and switch to it. So you can actually have like an older version of a particular service running at the same time that you have a newer version of it. In fact, we have a session later on in the week on Thursday where we have a demo of our technology preview where we'll actually show updating like glance from an old version to a new version and have them running side by side in a Kubernetes infrastructure. So it's pretty cool stuff that we're putting out as a tech preview so that we can get feedback from our customers.
So from a live migration perspective, if you sort of have a procedure to live migrate off and who may live migrate back, is containers going to change that at all? Is that going to help at all?
I mean, you'll still want to move your workloads if you're like recycling certain components, especially in the network. But in general, conceptually, you can do some components without having to move any workloads because you'll have the old and the new running side by side and you can flip them. So part of our work with this containerized control plane and containerized OpenStack is to work out all those upgrade considerations because we want to make it simpler for our customers to upgrade without having to do anything with their workloads. And so this is part of the step of improving that overall situation. So this is a picture of Airship. You can see on the right-hand side you have Kubernetes. So Kubernetes just has worker nodes. And so what we do when we lay down the OpenStack application on top of a Kubernetes infrastructure is we label those the nodes, either control or compute. And the compute nodes actually have KVM running, and everything's containerized, including libvirt. And so then we have Helm charts and a repo, and we use Airship, the different sub-projects of Airship, to deploy OpenStack in a containerized mode so that basically all Keystone Swift, everything that's running up there is a container, and it's just running inside of a Kubernetes infrastructure. So it's quite a big change, and as I said, there's an advertisement here for the session on Thursday. Please come out and look at it because it's really neat to see the actual demo of how it looks from a Kubernetes perspective, and you're laying down a containerized OpenStack deployment. And so this is going to be a big change, but I think it's really going to help us with upgrades and also scaling up an infrastructure and scaling down an infrastructure because everything is going to be a container running in Kubernetes. So part of our plans are upgrading to Cloud 10. So we want to get to a single Lifecycle Manager. So as we go forward, we're going to be depending on Airship to be our single Lifecycle Manager. So we're providing a crowbar to crowbar upgrade and a CLM to CLM upgrade, and also a Helium 8 to a Cloud 9 upgrade. And then we're going to converge on the containerized OpenStack in Cloud 10. Okay, I'll turn it over to Rick.
Okay, so let's talk about the Cloud 9 updates. We very often get requests about IPv6 support. As TR already said, in Cloud 8 we support IPv6 tenant networks, so basically the IPv6 traffic between your VMs and your projects. So what is new is the IPv6 support for the APIs, for example, so all the control plane networks. We decided to go for a single stack here. So you have to decide either you go for IPv6 or IPv4. And as the network technology is so different and you have to reconfigure all your routers, switches, and so on, there will be no conversion from IPv4 to IPv6. So you have to redeploy the cloud or set up a new cloud. This update will be available in summer 2019. So will be one of the first updates in Cloud 9. A next update will become, we are working on already, is GPU support for SUSE OpenStack Cloud. There we're looking at two use cases. So the primary use case is that we want to provide PCI pass-through for NVIDIA GPUs. There it's actually so that you have one GPU for one VM. So you need as many GPUs as many guest VMs you want to run for the OpenStack. And actually, if you look at the diagram in case 1, there you have this. So one VM per GPU. And this we implement via OpenStack flavors. And as this is not very efficient, we are looking at the second use case, where we want to share the GPUs across multiple VMs. It's so-called vGPUs. There we depend on a SLE integration, actually. So the SLE team has to integrate the NVIDIA driver for supporting vGPUs. As soon as it's implemented in SLE, we will pick up these changes and do the additional OpenStack changes on top. And there you can have, again, the diagram, multiple VMs per GPU. The other requested configurations are, for example, FPGAs and other GPU vendors. Is anyone using a different GPU vendor or is looking into it?
I'm primarily looking into
AMD, okay, that's good feedback. And the third request is that we want to provide discovery and provisioning with Ironic, so bare metal.
Sorry, so you're saying with bare metal you can use GPUs?
So the bare metal use case is Ironic is not that you have a VM running, but you have a bare metal server which is then provisioned via OpenStack, and then you can have the GPUs into the provisioned via Ironic, like the driver setup and all these things.
I mean, you're using OpenStack as a machine lifecycle manager, basically. Yeah, that's what Ironic does. It's machine lifecycle management.
The thing we want to change there is we need to make our cloud solution detect those bare metal machines that have GPUs and then manage them in a separate way so they are off-layer and they can be all detected. So the admin doesn't have to do it manually. That's the change.
Just to populate the GPUs so that they can actually be allocated as resources.
So they don't become part of the shared pool, they still be dedicated on Ironic.
Yeah, it's dedicated. And as TR mentioned in the beginning, we want to make the operators' life easier. So we want to have a better integration of SUSE Enterprise Storage and SUSE OpenStack Cloud. So there we have delivery phases. So what we already did is we provided additional input models for CLM. So you can define your SES settings once, and then it gets used in all the OpenStack components. What we just recently delivered as an update to Cloud 8 is the export-import feature, which means you export in configuration, in SES configuration from SES, take it, place it on a special location on your CLM control node, deployer node, and then CLM will take this configuration and automatically configures all the OpenStack components. And the same we want to deliver now as an update to in Cloud9 Crowbar. There we provide a new bar clamp where you can upload this SES configuration, and then the bar clamp will configure the SES settings once, and they will get reused in all the other Crowbar bar clamps. And we have one bar clamp per OpenStack component. Another feature which is actually for the operators, because it makes the operator life easier, is, as Tia already said, we want to provide watchers as a tech preview. So basically, Watcher uses OpenStack Monasca monitoring for monitoring the infrastructure, and then the operator provides policies, and based on these policies, Monasca is optimizing the resource consumption across the compute nodes. So let me give you an example. You have, for example, 2 compute nodes which have a high CPU utilization, and then Watcher detects this and spreads out the CPU utilization across all compute nodes, so that all compute nodes are in the same range of CPU utilization. Another example could be, for example, that power consumption, that you want to reduce the power consumption across your compute nodes. And for all this, Watcher uses live migration of VMs. And the operator has to do nothing. It's all automatically done. And as is in Tech Preview, we are looking out for your feedback.
Oh, so this is the Tech Preview in Cloud9, maybe incorporated in the minimum feedback?
Yes, potentially, based on the feedback from the customers.
So this is going to be a automated live migration, similar like a V2V, VMware situation?
Yes, that's exactly the use case.
So it'd be something similar to DRS, what VMware DRS does. You set a policy that says if you have a host that's too hot, move some of the VMs somewhere else to reduce the consumption. But you can set a policy for anything that you want. So it could be power consumption, it could be spreading workload out. It's really up to you, but this is the primary use case that was requested by some of the customers that asked for this. And so we're going to test this particular use case. There's no reason why you can't make a policy to do whatever you dream up. It's really up to you how you would use the performance metrics and make a decision to do so.
I mean, I'm speculating that you can probably still save 10 AZs. Is it a requirement to be within an AZ? Or?
It's up to you. It's how you write the policy. So we'll test like a single policy just to move stuff around, probably within like one availability zone or something.
Okay. Another topic we are looking into it is scalability improvements. So we are knowing that clouds are getting bigger and bigger. And we just started recently a field engineering squad, which is looking into growing with the customer demand. So as customers come up with new large cloud deployments, we are looking actively into this, and we want to make sure that we can support this. So as an example, in the second half of 2019, we are looking into the verifying and qualifying the compute nodes scale from 1 to 2000. And there we're actually looking into 3 key areas. So the first one is we want to add region support to the lifecycle managers so that you can have multiple regions per cloud. As a second step and key area, we are working on multi-site use cases so that you have multiple clouds in different sites. And then, because it's the next logical step, federation of security and then identity. Another very interesting topic is SDN integrations. So in SDN, you have a plugin to the Neutron server. Right now in Cloud 8, we already support VMware NSXV, which is ESX only. And for Cloud 9, we're looking into VMware NSXT and Juniper Contrail, which supports KVM and ESX. And additional to this, we are looking into Cisco ACI. There was actually today earlier a session from Mark Darnell, and this is repeated tomorrow morning, 10 a.m. It's called Networking at SUSE, and there you can get all the other details about the SDN integration. Last but not least, we want to improve our current monitoring situation. There are, again, two areas. The first one, we want to improve the current Monasca implementation. So we want to do the lifecycle monitoring of the VMs, correlation of VMs, of events across compute nodes, VMs, and so on. And then we want to provide better out-of-the-box defaults. So right now, the operator has to define all the defaults, and we want to provide this out of the box. And for Cloud 10, we want to introduce Prometheus. So Prometheus should take care of all the compute and control plane monitoring, and then forwards this to a Grafana dashboard. And there we want to provide a common view across all the products which use Grafana dashboards in SUSE.
This question, so this may be available now, I'm not sure, but is there a way to use this to provide that to tenants so they can sort of monitor their tenant environment without HOS admin interaction?
Right, so this Grafana and Prometheus is going to be mainly the infrastructure. There is a way inside of Monasca to monitor tenants. We haven't finished the qualification of it, but that's something that we're actually considering doing. When you turn on the tenant monitoring, it's a pretty heavy tax with performance and data flow. So that facility does exist in Monasca, but it's not necessarily meant to be in this particular Grafana Prometheus implementation. So part of the reason we're looking at this in Cloud 10 is right now when you get SUSE storage, it comes with Prometheus and Grafana. And also our container as a service platform comes with Prometheus and Grafana. So it's a logical extension that we would plug cloud into it as well, so that each of those products is using a standard mechanism presenting things in a Grafana dashboard. And people really know how to customize Grafana to do exactly what they want. So, you know, we provide something out of the box that's pretty good to get you going, but if you're like a Grafana guy, you just like can go crazy and put all your dashboards together. So I think it's really where the community's going, but we're not like stepping back from Monasca, because there's a lot of things inside of Monasca around metrics, especially in metering, that Prometheus and Grafana doesn't have. So we're going to have actually both of those capabilities, and we have the ability now to present Grafana dashboards from a Monasca implementation. So we're kind of doing a bit of a hybrid, so that we're still keeping that Monasca in our offering, but we're also providing this. So if you don't need all the deep details that come out of Monasca, you can just run your operation with Prometheus and Grafana.
So, with the monitoring with Monasca and Prometheus, I was asking about the tenant stuff. One of the things that, at least in our OpenStack deployment, is that we focus heavily on, we give AZ spaces to certain teams that they can go wild in there. And wild in the sense that they can do what they want and they're not going to screw up everyone else's work. But some teams would like to have the ability to have metrics and monitoring and stuff like that from the OpenStack level for those teams and for that. So I was wondering, is there a way to not have it be horrible and be able to have either Monasca or a Prometheus Grafana combo for per AZ kind of things delegated to certain tenants and users?
I mean, the way to make it not horrible is to cut back on the metrics that you collect. So if you take it right out of the box, you're going to get a lot of data. And so you're going to have to like trim back and really figure out what you want so that you don't spend a lot of time collecting a lot of data that no one looks at. Yeah.
Okay, and now back to TR with the other Cloud 10 teams.
Okay, so we're actually working on the final, well, actually the initial plans. We had our first Cloud 10 planning meeting. And so we kind of talked through some of these things, but really the big thing in Cloud 10 is containerization of the OpenStack components. And we're using the Cloud 9 tech preview to prove that out and get feedback from customers and partners. So that's going to be the default configuration in Cloud 10, fully containerized, running on a Kubernetes infrastructure. As we talked about with Prometheus and Grafana, we're adding in new monitoring capabilities, so it's a new option. You can use them or not, but it makes a lot of sense because we have this new infrastructure based on Kubernetes, and we have that base monitoring already included in our products, so it's a natural extension of that. And as a result of picking up and using Kubernetes now, we're using the HA qualities or capabilities of Kubernetes. So it's a logical progression of if we change some of the infrastructure, that we start to use the availability capabilities of that particular infrastructure. We're also looking at adding a new common installer for our cloud infrastructure. Since we're using Kubernetes, our container as a service platform, as the basis to deploy the containers on, we're also going to provide an installation mechanism so that you buy cloud and you can lay down the Kubernetes as a result of the installation of cloud and then deploy all the containers on top of that. So our new installer is going to take care of that for you. The other thing that I mentioned was this whole idea of using a new Lifecycle Manager based on Airship. So that is part and parcel of the whole containerization. And then we're going to continue to look at new accelerators and new things in the market. So when you were mentioning about the AMD stuff, are you looking at the SRIV GPUs?
Yeah, that is a large chunk of it. Some of it is also we want to pull in dedicated GPU resources for certain types of tasks and things like that. But a good chunk of it is like we have those particular GPUs and we're using the vGPU functionality as well as the OpenCL stuff and some of the new Vulkan things and things like that. It's just a wide matrix of things. Some of the experiments that I've seen and been working with, we're trying to lean towards more of the open APIs and the open ecosystem stuff, which has tended us towards looking more at AMD stuff, even though NVIDIA is currently the leader right now. We like the more open standards to work from where we don't get boxed in. Because it also means we can also interop with Intel stuff for lighter weight stuff.
Interesting. Yeah, because I've been actually looking for someone like you because I see the advantages of some of the AMD technology, but I haven't found anyone who's really into like using that instead of NVIDIA.
All of it is really exploratory. We don't really have anything special to go with it, but it's been something we've been poking and prodding for a little under a year and a half now, with various types of architectures and infrastructure types and things like that. It's been very difficult so far because of how narrow the view has been on the horrifically expensive and very closed and locked in NVIDIA stuff that people have been like focusing on lately. And well, up until recently is more accurate way to say it.
Interesting. Yeah, we have a close relationship with AMD as well as Intel, but so I've been talking to him about that as well. And in the community, I haven't seen a lot of SRIV GPU work going on.
I participate a lot in the upstream communities, a lot and the real problem is that when the hardware is hard to get access to, that's one part of it. But the other part of it is there's this weird bootstrap problem where there's nobody who's really started kicking off those efforts to encourage the development of these things. And so like somebody has to take that first leap into like building something that people can use, and then that just kind of spreads out. somebody's too scared to make the first move is really what it comes down to. And a large part of it is because everyone is kind of scared about being different. It's been really, really hard to find anything or anyone who is able to support that something other than CUDA is really, really what it is. Like, I don't want to use CUDA. I really don't. I don't want to use CG. I don't want to use CUDA. I don't want to use any of that. But everyone else is scared. And they keep going back to that because there's 5 years of toolkits and libraries. And, like, to be blunt, even game engines are like relying on stuff like that. And it's just why? And so it makes life very difficult if you want to be that guy who wants to use more open things. It's just somebody has to take the first step, and I don't know who's going to do it. And we're certainly trying to find ways to use these interesting things. It's just, I don't know.
Yeah.
That's why I was kind of interested in the VGPU thing, and when you asked about the thing, it was like, yeah, I'm interested in AMD stuff, also interested in Intel stuff for more low-cost things, but like basically because AMD and Intel for the GPU side of things are leveraging the same APIs and ecosystem and technology things, it is a lot more attractive than what is going on with the very closed NVIDIA tooling.
Interesting. Yeah, I'd like to talk to you some more about after the session. So that's what we had to talk about today. I mean, are there questions in general or comments? Oh, thank you very much. Hope you guys have a good evening.